Hey guys, my name is Ethan, this is Cobra, and welcome back to the series where I teach you how to analyze and visualize data in Python. Today we're talking about filtering data, so we're going to be removing certain rows that don't meet certain criteria, and we're also going to be talking about the rather complicated way that you actually perform multiple filters at the same time. Of course, if you find the video helpful at any point, then consider liking to let me know and subscribing so you don't miss out on new videos in the series. But with that out of the way, let's get into it. And as seemingly always in this series, we have the same imports and the same data set, so I'm just adding the boilerplate code in. However, this is actually the last video where it's just going to be the same sort of thing. They've all, up until now, used the same data sets because it's all just simpler to talk over. But from the next video, we're actually going to be doing some more imports and we're going to be using some different data sets. So that's going to be exciting. But if I just run this, you can see that everything works and everything's still fine and it's all well and good. For now, however, we're going to be focusing on filtering data. And what I'm going to do is show you how to filter it, and then I'm going to explain it afterwards because I think that makes a little bit more sense. So we're going to do df2 equals df, and in square brackets, df views is greater than or equal to 1,000, and then we're going to print df.head, or sorry, df2.head. As you can see, we now have a data frame. Actually, if I get rid of this, and I might show it off. As you can see, we now have a data frame of 118 rows that only includes days where I got more than 1,000 views, or more than or exactly 1,000 views in any given day. You may be looking at this and thinking, how the hell does this work? Now I'm going to open a separate cell to quickly show you the result of df views greater than or equal to 1,000. So if you go back to episode 5 real quick, you'll remember this little line here if you watched that video, where we created a new column and we set the value of that column to equal df likes minus df dislikes. Now, what this did is it went through row by row and subtracted the value that was in the dislikes column from the value that was in the likes column. And this created a series which was then attached to this, and it was then attached to the data frame. It's the same sort of logic here. So this is going through every row and checking if the views column is greater than or equal to 1,000, and then it returns this. So it returns a series of booleans, and this isn't like too useful because it's just false, 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 and true, 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 true. However, of course, if you've seen the data set, you'll know that only really the later rows have views anywhere near this high. But the idea is that it returns a series of boolean values, so it either return true or false. And then when it goes into here, it'll index this, and then essentially it will go through checking each of the rows, and then it will compare that to the true or false, and essentially this is telling the data frame what to include. So you could, in theory, just include like a list of false, true, and it will take every other row, and that's essentially what this is doing. So it's sort of like a binary. I don't really know how to explain it properly, but you know what I mean. It's just kind of. It's essentially going through and cherry picking each individual row based on a specified, in this case, df.views greater or equal to 1,000 criteria. Now I'm going to put that equals true. And that also explains kind of the weird syntax, because this would need a series to index it. Now, of course, once you've filtered by one criterion, you may want to filter by multiple criteria at once. So you may, for example, in the example that I'm going to do, you may want to filter, or you may want to create a data frame, where the views are greater than or equal to 1,000 and the CPM is greater than 0. Now, the CPM is kind of how YouTube tracks the monetary statistics. And this is where the syntax gets really rather confusing and kind of awkward to deal with. So I will kind of show you what it is, and then again, I'll explain it afterwards. So we're going to have df3 equals df. And then we're going to have our same df views is greater than or equal to 1,000. However, in this case, we actually need to put this in some brackets, and then we need to do an ampersand, and then df CPM is greater than none. And we're not going to include equal because we just want those figures where the CPM is greater than 0. And if we do df3.head, we'll see that actually I'll just kind of show that some extra columns would have been taken off. So you've got 81 rows now instead of, what was it before? It was 116 or something? 118. So as you can see, there were some extra rows taken off. And if we go over here, we can see that, you know, CPM is all like above 0. It's not really the best. It works, I assure you. So you may be thinking, what on earth is an ampersand? Wouldn't you just do and in Python? And the answer to that is no. And that's because this is acting as like a binary implementation. And the and is just how the operator was overloaded in this particular instance. So to show you that, I'm going to launch a terminal. And I'm actually going to launch Python. We'll launch 3.9. And it will make it a little bit bigger. Can I do that on the fly? Nope. Okay, give me 1 second. Okay, there we go. That's a little bit bigger. So the ampersand is a bitwise and operator. So the easiest way to show this is with two integers. So if I were to convert, say, 156 to binary, we'd end up with 1, 0, 0, 1, 1, 1, 0, 0. You can ignore the 0b, that's to show you that it's in binary notation. If we did the binary of 171, instead we have 1, 0, 1, 0, 1, 0, 1, 1. And there are multiple bitwise operators, so there's the bitwise OR and the bitwise, XOR. But the one we want to focus on today is the bitwise AND, because that's the one we're actually going to be using to create multiple filters. So essentially, if you were to do 156 and 171, you would come out with 136. And if we did bin 136, it's 1, 0, 0, 0, 1, 0, 0, 0. And if you look closely, we can actually compare each individual bit to see if it matches the criteria. So 1 and 1 equals 1, 0 and 0 is 0, 0 and 1 is 0, because it's an AND, it's not an OR, it's not an XOR. 1 and 0 is 0, 1 and 1 again is 1, 1 and 0 is 0, 0 and 1 is 0, and 0 and 1 is 0. So it is essentially comparing every bit, and it's checking to see if they're both ones. So if we go back here, because of the way that Python Truthy checks work, this is essentially doing one filter, it's doing then another filter, and it's then checking to see which ones are both true, and then only including those. So if some of these are true and some of these are false, then it goes, nope, not having it. If some of these are true and some of these are false, then it goes, nope, not having it. It only takes the ones where the row is selected as true both times. So hopefully that makes some degree of sense. And then, of course, if you wanted to do more, you would just continually add more filters with the ampersand and not the word and, because they do actually work differently in Python. So that is all I wanted to talk about with the filtering. It was quite a simple video, but because of this bitwise explanation I wanted to do, it was in a video on its own, although it probably would have been better on its own anyway, to be fair. Of course, if you have any questions about what you've seen, maybe especially about this, then don't be scared to leave a comment, or you can join the Discord server using the link in the description below. But yeah, with that, I'd like to thank my awesome patrons for being unbelievably amazing. And I will see you next time, where we talk about imputing values. So we're going to be essentially filling in some missing values in our dataset.